And we're live.
All right, good morning, everybody. Welcome to our Friday edition of All Things 3D. Today is November 14th, 2014, and it's All Things in Review, or 3D Things in Review, 3D in Review on All Things 3D. I'm your co-host, Chris Kopak.
Hi, and I'm Mike.
Hi, Mike.
And we have a special guest crasher today, Tom, who's got a neat product that he's going to talk about a little bit later, and he's welcome to join in our commentary on the news as well.
Yeah, welcome to the show, Tom.
Yeah, Tom Bielecki, founder and CEO of Print2Peer.
Great. Yeah, we can't wait to pick your brain on this great new product. One of the few products out there at this point that allows you to print remotely to a lot of these 3D printers like the RepRap style printers, MakerBots, etc. So we'll go into that in a little bit. But first, we're going to touch on some news items. How's that sound, Mike?
That sounds great.
Okay. Well, I think I'll jump right in, and we'll go into our news items. First thing I saw this week was this is kind of big news, is Full Spectrum Laser, one of the competitors to Formlabs. So Full Spectrum brought out a Kickstarter earlier this year with the Kickstarter campaign for their Pegasus Touch SLA printer. Apparently they did a round of investment funding and they just raised $10 million in growth equity investment from Summer Street Capital. And so some people are investing some money, so that's good news for those Kickstarter backers that were wondering when they're going to get their printers, if they're going to get their printers. Full Spectrum, I know, I've seen them at a couple of trade shows now, and they have been around the block for a while. They have been a laser engraving cutting company for quite some time, and they unveiled this Pegasus printer on the Kickstarter, and it's basically a direct competitor to the Form 1 Plus, and it's looks like a pretty promising printer. I haven't printed on one myself, but I'd love to get my hands on one. So this is the under $3,000 Pegasus Touch, and just showing you that a lot of investment coming this way to the 3D additive manufacturing world. $10 million. So good on them. Good for those Kickstarter people.
Yep, sure is.
So.
Yeah, actually we've got a couple of Kickstarter people coming out here shortly. We've got an update from another company that we talked to as well that we'll go into in a moment. Chris, why don't you go into your next item real quick, and then
Sure.
I'll come back.
Okay. The next one here is an update. This one is Solus. It's a high-resolution DLP 3D printer, so DLP SLA printer. Like we've talked about numerous times in the last few months, it looks like 2015 is going to be the year of SLA. We're going to see a lot of these machines coming out. The products themselves getting better, the resins becoming more widely available, some competition out there. So a lot of competitors to the Form 1, and instead of using lasers, they're using DLP projectors. We have a friend from Santa Barbara who successfully did his round of Kickstarter just a few months ago. Brad from the Little RP. I've got one here in-house, and the prints coming off of it are just amazing quality. And so just excited to see more competition out there. This one, the early bird specials were about $1,000, which offers you, let's see what the build envelope on this is. So 25 micron XY resolution, and able to print features below 100 micron. And does it tell us the actual build envelope size? I think it's in here somewhere. Anyways, you can pick through it, and you can use it. You can pick from a list of projectors. So instead of using a laser, these DLP SLA printers actually use a projector a DLP projector to project and cure the resin. So here's the actual build envelope size. So it's got about almost a 14.5 centimeter by 11 centimeter by 200 centimeter build area, just with this small size projector. So pretty cool.
It looks like these will be great for jewelry designs.
Yeah, especially since they've got these cast resins that are out now, that you can, that burn out clean. So Maker Juice, Made Solid, our friends over at Made Solid, they have a new cast resin. Form 1 even has their cast resin out that's specifically designed for the jewelry market and people that are intending to cast their objects.
Yeah, there's some caveats though, and with these cast resin is the amount of time it takes to burn them out cleanly, and
Sure.
you're looking like half a day, 12 to 14 hours, and it has to be over a precise temperature range. It's just not set it to one temperature and it burns it out. It has to be a gradual thing, but that seems to be the norm for cast resins in the UV spectrum. So it's nothing new. However, I was hoping to see maybe some changes there, maybe expediting that burnout period if you wanted to bring it into the dental or some other areas. That's just too long and it doesn't supplant or replace the milling techniques that they use now, which can be done in 2 hours. So I was hoping that it would be faster, but it is not.
Yeah,
but
yeah, go ahead.
One other thing. The other thing I wanted to point out, this is actually one of we got a new section called the update, so that where we're going to take things that we've talked about in previous episodes and see where they're at, and hopefully Tom will also be part of that group later on as well. And this was an item that was in our update area, so thank you, Chris, for taking the time to go through it again. I think it's a very nice looking SLA printer, and I think it's reasonably priced in the way that it's made. And all hats off to him. He told me, because he sent me an email, I don't know if he sent you an email as well, Chris, but that he's not, I guess he's reached out to other people and they haven't really mentioned anything in their news channels, so it's kind of sad. It's like you get one shot and then it kind of goes away, and I hate for that to happen, so that's why we're giving him a shout out today. All right, Chris, go ahead.
So I just think if any of our listeners are out there looking for a DLP or an SLA printer, they're looking to save a little bit of money. Best way to do that is on one of these crowdsourcings. Again, it's kind of a crapshoot because some of them obviously come through, others do not. But on these 3D printers, even though they are typically plagued with delays. Most of the time, they at least deliver the product as promised. So you're kind of gambling a little bit with crowdfunding, but it is also a great way to get a little discount on some of these units.
Okay, well, I'm going to go into my news item now, and as you can see behind me, the big thing this week, in my opinion, was how the ESA finally landed their Rosetta spacecraft. Actually, it's a module off the Rosetta spacecraft onto a comet. How cool is that? But from a 3D perspective, maybe you know, maybe you don't know, but I know it really hasn't been mentioned in the news, and luckily Sculptio has kind of brought up in a little article that they modeled the asteroid. And I think, yeah. So here it is. You can rotate it. They modeled it so they could print it out and actually determine the best landing spot. So how cool is that? So essentially they use the same kind of techniques that we use in order to map our own terrains. They take multiple images using stereographic and what's the other technique? It's not coming to my mind. Photogrammetry. And then by applying those techniques, they come up with a 3D model. And they use this in order to determine its location. The sad thing is they didn't know the material composition. A lot of rumors are that they're made out of ice or have an ice sheathing, but that doesn't seem to be the case here. And they have, what would you call it, grappling hooks that were supposed to actually become part of the surface there to keep it down. And I don't know, I haven't seen an update if they were actually able to secure that. And they have a concern now because they wanted to drill for a sample and analyze it so they can send it back, but they're afraid to do that because they think it might project this thing back into space. So I don't know if they've gone ahead with it. I don't know the status of it, but it's real interesting, some of the things that they have to think of once they're there. But again, it doesn't appear like it has an ice sheath like a lot of things. And plus it doesn't have all those little inverse staglamite, or what did they call an inverse? Who saw the movie Armageddon? Do you remember what that comet looked like?
Yeah.
Yeah. Well, obviously it doesn't look anything like that. So
I mean, the pictures that they had off of this comet were mind-blowing. They have dunes on this thing, and we gotta pull up we have. I think I have some images. I have an image.
Okay. Well, while you're finding those, I'll just kind of rotate around So as you can see, it just kind of looks like a lump of clay out there. And
what's the comet? What's the name of this comet again?
It's got a weird name. Let's see if we can bring. It should say it here. Tom, you want to pitch in?
I don't remember the name off the top of my head.
Yeah.
Oh, there it is, right behind there.
Not now. Jeez.
Philae.
No, I think Philae is the name of the landing craft.
Oh, right.
It's a two-word. I think it's a Latin. There it is. Chumarov. I'm not even going to try. Gerasimenko. Yeah, so that's the name of the actual comet.
It would have been a nice surprise.
67P. I'm sorry?
It would have been a nice surprise if that comet was made out of PLA.
But here it shows the different landing site options that they had.
This is the one I'm looking. This is the one I'm looking for here.
All right, go ahead and pop it up.
This is so this is Comet 67P here, and over here is the Federation space dock, the Deep Space Nine spacecraft, and over here's the Galaxy Starship.
I don't remember those. Where were those?
Borg cube. This is from Star Trek.
Oh, so that's the size equivalent.
Size equivalents compared, somebody took the time to scale these things. They already have a really detailed map or scale map, I know, of all the spacecraft from sci-fi movies up against each other. So then somebody took the comet and added that in, and just took a few of these for reference. But you can see, I mean, this comet is actually pretty massive.
Yeah. I think that's a good point. So they did have, even though, keep in mind that they went billions of miles, is it billions of miles? Over a 10-year time frame. I think the project started 10 years ago. I don't know when it was actually launched. For some reason, 7 years sounds like something that I remember. But imagine traveling for 7-10 years and then saying, okay, I'm going to land on something the size, even though it seems like it's large compared to those other objects. There is no automatic landing tracks or beacons or anything. It's just a mass in space. So, it's just really cool.
Mind-blowing.
And I don't know if you know a little bit about orbital perturbations, but all that has to be taken in. If it weren't for the computer power that we have now, we would have probably overshot this. So hats off. Again, remember that it's the ESA, which is the European equivalent of our NASA, and even though NASA did play some role into it, it was mainly the Europeans that did this. So hats off to them. And the Chinese have done some things, and the Japanese and the Indians. Everybody is taking their mind power and doing something in space, which I think is really cool. So I'm going to go ahead and move on to my next one, since we are still on the subject of space. So we know about space. We know about the NASA's push to put up a 3D printer, but did you also know that the ESA is also thinking in the same realm? So this is a concept model, and I don't know if they've approached any further. I don't think they actually have a working model, but they're looking at how they want to do this. And one of the things that they said was concerned is that they don't want a printer to introduce any environment effects to the International Space Station by, as we know, ABS and other materials can be somewhat toxic. So they're thinking of strictly PLA, and obviously they're going to have to take into consideration some of the issues that come along with doing FDM printing. But I don't know if you looked at this article here, but it talks about, where does it say? It doesn't say FDM or FFF. It uses a whole nother term. Let me see if I can find it. Well, the link is in the show notes, so if you want to look out, but it calls it the technique they want to use is a little different, and I have never heard of it before, but it appears to be the same thing. So maybe the Europeans have a different word for it. But I think it's pretty cool that we have more than one, what do you want to call it, space agency looking at providing something that can be used in space. And as we talked about many times before, Chris, this just seems like a no-brainer. A lot of the parts take a long time to get up there. They can only store so much in inventory, but they can always push up data and CAD drawings in order to print things in STLs. So, we have an infinite repository. So the more items that you can literally manufacture yourself, the better you can keep yourself out of trouble. If you remember Apollo 13, what they had them do, which I thought was very ingenious. So this just seems to be an extension. So who knows what will come out of that. Want to add to that, Chris? I'm sorry, go ahead, Tom.
My understanding from Made in Space is that they actually slice the files on Earth so that they can optimize a lot of the tool paths of the printer, and then they actually send the G code up to the space station.
Makes a lot of sense.
That's an interesting spin on it.
Mm-hmm.
Well, astronauts are really good at flying spacecraft and performing tests in the laboratory, but that doesn't necessarily make them experts at G code. So
that's right.
I think leave it up to the experts down here at home. Send it up,
Yeah, and it's not like G code is really that byte intensive. I mean, they're not that large files, so I don't think it would be that much of a deal to send those up. It's not like standard mesh files or even images. They're very compact, and even for complex items, you're only looking at most a couple of megs for a G code file. So it makes sense to me that they would go in that direction, and then you could zip it and make it even smaller. I can imagine their computers up there using zip or 7-Up or whatever the other application is. So it'd be kind of funny. Oh well. Moving on.
You don't want your WinZip trial to expire on the space station.
Exactly.
Yeah.
Well, I don't think it actually expires. What do I use? I use a product. Let me see what.
Your space station hasn't backed up in 20+ days.
That would be funny. Let's see what I have to actually bring something up. Maybe I don't have it on this one. Oh well. But it's another program that I use that seems to do a much better job at compression. It's 7 something or other, and I use that extensively. It's an open source application that they hope that you'll send them some money. I sent them $10. So fun on that. Okay, so Chris, on to your next item.
All right.
So that we can finally get to Tom.
Yeah. So this one is from our friends over at Fabaloo, fabaloo.com. FABBALOO.com, and they say, this is from November 10th, so earlier this week, new process could lead to consumer-priced 3D metal printers. Some students over at the University of Southern California have come up with a new type of process that's similar to SLS or SLD, and this one, but they're calling it selective inhibition sintering, SIS, and it offers a very different method. Instead of fusing the object itself from a bed of metal particles, they merely deposit an inhibitor solution on the perimeter of the object. Then the powder bed is fired in a conventional furnace, melting and fusing metal particles that have not been inhibited. Inhibited particles remain loose, so they're able to basically cheaply and effectively do metal sintering using this process, and it could pave the way for some kind of cheaper alternatives to the current SLS methods out there. So pretty exciting.
There was something really interesting I found about this process. It's that it has a very specific use case in that um, for print beds where most of the print bed is full of objects to be printed, this is a
Uh-huh.
more effective process than the reverse.
Oh,
Um,
wow.
but I think the majority of print beds are mostly empty, which means that this process isn't as effective for those types of prints.
Got it.
So if you're filling up your entire printer, then this might be the solution that you want to go after.
Okay, well, then there you go. But looking forward to seeing more of this, and seeing how some of these people are kind of playing around with it. Maybe get some YouTube videos of this thing up in the coming months, and see what they're working on. See how other people are thinking outside the box. It's always good to see how people are tackling these engineering type problems, for especially because the metal printing obviously being the holy grail of the additive world.
Very, very cool. Yeah, as you said, it is the Holy Grail, and I'd like to see more being done in this area. In fact, what was I thinking of the other day? Something that I wish I had in metal, and think of ways of casting it, but uh, I can't think of it right now. So I'm going to move on to my item, and that is Make just had an article come out on the 11th called Untether Your 3D Printer, which will be a segue into Tom's product. But this is an open source product. When I originally read the article, I thought, well, okay, they're going to tell you how to make their own, but it appears it's a Octoprint. Tom, you probably have heard of this, and you can probably expound upon its strengths and weaknesses and how yours compares to it. But Make is a real good location to go to if you want to try different projects and do things on your own. And a lot of problems with open source type items is you have to put a lot of work into them before they actually work. And so it's nice, and I'll use that as a segue to introduce our guest, Tom. And I don't want to mess up your Bielecki,
Bielecki.
who's the CEO of Print-to-Peer, and from what I have gathered, and I'll jump right to your website, it is something similar to that in that you provide a technique or a method in order to control your printer from afar. And that's kind of the theme of this particular 3D in review, and I thought I'll just give you the platform now. If you want, I can just kind of use your background here and flip through it. Um, However you want to do it, but I'll bounce to it. So this is your website, and from what I gathered, you can sign up and you have like a web service that then comes out and sends information back to the product itself. Is that correct? Or
That's right. So you can log into this website from anywhere that you are, from a phone, a tablet, or a computer, and you'll have real-time control over the printers that you've connected to your account. Um, and yeah, when we started 3D printing about 3.5 years ago, we had a couple of different kinds of 3D printers in our office, and the problem was that each 3D printer that we had actually had a different process to send files into them. You'd have to go through 3 different pieces of software to repair the files, slice them, and then drive the printer itself. And we thought, if 3D printing is supposed to get easy enough that my mom can do it, she's not going to be going through those 3 pieces of software. It needs to be a lot easier. And as software engineers, we saw that if you could just have a simple website that you could go to send prints, it would be a lot faster and a lot quicker.
okay,
Technology always optimizing and making things more efficient. I mean, that's really what it's all about. That's what technology does at every turn, is just how can we optimize the market? How can we make a process more efficient? So I mean, you're doing a perfect job here, just identifying an inefficiency. I mean, 3 pieces of software, that's not practical.
Yeah, exactly.
Yeah.
We saw software automation. It's being used to change so many industries out there, and 3D printing being as slow as it is today, it could get a lot better and easier.
Oh yeah.
Now I see you obviously have an Apple. What do you want to call it? iMacs. I don't.
But
Jeez. iMac in the background, and then you have an iPad. So is this an app as well, or is it all still web-based?
Yeah, so this is all web-based for now. We are looking at creating some mobile apps down the road. Um, but actually, one of the benefits of having this connection to the web is we can build on a simple programming interface that any other application could tie into. So if you do have, if some other developer has created an app, like if it's IKEA that has made a marketplace of all the 3D files that they have, they can actually put in a print button that goes directly to your printer. So there's a lot of new opportunities that opens up when software developers can work on 3D printers.
Yeah,
And
well,
so,
I'm gonna be the devil advocate here. So this would automate something going to your printer, but as we know, we still have to automatically, manually put in our filament, make sure our bed is adjusted properly. Are you seeing that the 3D printer itself is going to start automating or simplifying that process so you can have a full turnkey system, Tom?
Yeah, so the problems there are mechanical for the most part. Like most printers themselves, they don't have many feedback mechanisms telling you, if a print is actually still running, or if you've just got plastic going all over the place. That's
Yeah,
that's one of the
I've
fears.
had that happen.
Yeah, that's one of the fears of everyone just leaving prints to run overnight. Um, so yeah, we're hoping to work with hardware manufacturers to improve the collaboration between software and hardware to make that possible.
get some feedback from the machine itself, on the fly. I think that's what a lot of these machines are missing, is really exactly what you're talking about.
Now, does your software allow a webcam to be installed?
Yes, it does. So we're
Cool.
using the standard Raspberry Pi camera to get a real-time webcam feed from the 3D printer. So you can see exactly what's on your 3D print bed at any time, and to know if your print is still going properly.
Okay. Now, you
So
mentioned the word Raspberry Pi, so
yeah,
obviously
so
you're going
so
to
what
need one.
happens, Mike? My understanding, Mike, the way this works is they have an image that you load up that goes on a Raspberry Pi. So, and tell me if I get anything wrong here. This is my understanding of it. I signed up for the website and I started checking out the software. And so I've got a Raspberry Pi and I've been wanting to use it as basically a remote print server. And that's what this lets you do, but it lets you tap into it remotely. You don't have to have a monitor and a keyboard even for that Raspberry Pi. You just load on their image, and it basically you can automatically connect to that Raspberry Pi if it's connected to the internet.
Yeah, you need a LAN connection or an EDIMAX type Wi-Fi USB dongle, if I
Yeah.
remember correctly.
So you just throw their image right on your Raspberry Pi, and then connect the Raspberry Pi up to your network or a wireless connection if you have that enabled, and then you connect your Raspberry Pi up to your 3D printer, whatever it is, and then you use their online interface to make all these configurations. Is that right, Tom?
Yeah, that's right. So it's actually kind of similar to how Chromecast, you can just plug it into a TV and then it's network connected. So for 3D printers, you just plug in the Raspberry Pi to the USB port, and then you can control it from anywhere.
That is so great.
Very, very cool.
Yeah, we
So,
actually have some friends that really need to link up with you that are working on a kind of a similar technology, but I think you're probably further on, and it looks like you even have a developer API. So our friend Brad Hill, he has that little RP machine, and there's a lot of people in the DLP, SLA, or even the SLA industry that are looking for exactly this, because a lot of users don't want to have a dedicated computer with a GPU or a graphics card driving these DLP SLA machines. They want to just have a little Raspberry Pi that powers the machine because it's got enough juice on it to do most of the operations that even like a little simple SLA printer needs.
Yeah.
But being
So
able to control it remotely is really...
hey, Chris, I emailed Brad last night to see where they're at on it, and they've made some progress, but I agree with you. Maybe, hopefully, they're watching this episode. I told them that we would mention that there are some other people working on something similar to this, but Brad, if you're watching, maybe you can hook up Tom, Brad, Tom. Okay,
Yeah.
there we go.
Yeah. So what we're seeing with 3D printer manufacturers is that they all see wireless capability as being the obvious next step for them, but most of them are hardware manufacturers. They don't have the necessary software development members on their teams to be able to implement this full thing. And it's not just adding wireless capability to one printer. Because this system works across 80% of the consumer 3D printers that are out there today, you can actually have an office that has multiple 3D printers connected through one central interface. So then you're just managing them through one system instead of needing a different workflow for each of your printers and a different software for them.
I think, again, you're just adding efficiency to the market here.
Yeah.
Yeah.
So
Very cool, Tom. Oops, go ahead. Sorry.
Yeah, I've actually got a demo of the system hooked up here. So we have, in our office, we've got two 3D printers connected. There's a PrinterBot Simple and a MakerBot Replicator 2. And they're both connected with a Raspberry Pi to our web service.
To the same Raspberry Pi? Or are they connected to different ones?
Yes, so right now they're connected to the same Raspberry Pi. You can actually have them either connected to the same Pi or to multiple Raspberry Pis.
How many Pis can be effectively used? I'm sorry. How many printers can be effectively used with one Pi?
That's actually something that we have yet to test. Theoretically, you could do 4 or more. The latest Raspberry Pi B+ model has 4 USB ports, so you could use all 4 of those.
And I actually have one of those coming today, as I mentioned in my email to you, Tom. So I will try this out, and I actually have 4 printers.
Can't wait.
Yeah, it'll be fun. So are you looking at possibly using the same technique for SLA printers? Like Chris has alluded to, Brad has an SLA printer, and currently you have to have a machine hooked up to it, and they're working on their own version of this. So I'm wondering, are you going to be looking at using SLA type printers, which obviously are a little more, where I want to go with this, different in the way that they present their G code. So
yeah, that's right. So yeah, since we've made this as modular as possible, you can we're adding in new modules to support SLA printers. So it works across FDM and SLA and getting into DLP as well. And in the future, we are hoping to get into some more industrial type 3D printers.
Does it work with the Form 1?
The Form 1, no, not yet. We are looking at...
Well, I've got a Form 1. I've got a Replicator 2, so I guess I'm good to go there. I actually have a Maker Gear. That's what attracted me to this. I said, oh, that's my printer there. So I actually have an earlier version of that. I also, currently, and I'm hoping to sell it soon, I have an Ultem Maker 2. So I don't know if you have a setup for that already. And then I also have a Casso Clear, which is a Delta printer. So I don't.
Yeah, the Deltas, the Ultimakers, the Maker Gear, the MakerBot, they're all compatible.
Essentially anything that runs G code.
Yeah, exactly.
So I have a question for you, Tom. How do you plan to monetize this? How is it? What's your strategy from a business standpoint?
Yeah, so we don't want to charge consumers themselves. If you have a Raspberry Pi and a 3D printer, you're already sort of that sliver of the population that knows exactly what they're doing and what they need. So you can download this for free directly from our website if you sign up. For actually monetizing this, we're selling licenses directly to 3D printer manufacturers so that they can have this wireless control directly on the 3D printer when you buy it.
Wow.
Yeah, and we've seen quite a bit of interest so far from 3D printer manufacturers. So, and going down the road in a few months, we're hoping to monetize on some of the materials that are going through the 3D printer. So, since our software allows you to print more things faster and easier, you're going to be using more consumables. And so, in our software, there's a catalog of all the different kinds of filament that you can put through your printer, with all the temperature settings already configured in there. So we're going to be allowing you to find new suppliers of your filament with ratings and all those different kinds of information.
Got it. Okay. Cool. Yeah. But for now, for the consumer, it's free. It's a free service.
Exactly. So you can get on top of it as soon as you need it.
Wow.
I can actually show you right now. we'll put through a 3D print and show you how easy the slicing is. So typically, yeah,
And
you
have the
need
live
to repair files.
This is killer.
Yeah,
I
so
gotta
I'm
get
gonna
me a Pi camera now on the way. I've got me a Pi, and I actually have been
Yeah.
using it to remote print.
Tom, we should have done an interview instead. Obviously, this is more of a 30-minute type thing.
It's
Sure.
great.
Yeah, so I choose an STL file, which quality and which 3D printer I want it to go to. You can have custom G-code profiles too. It repairs the file, it slices the file, it downloads it to the Raspberry Pi, and now the print starts automatically. So that entire print process has been automated.
Wow.
And there you go. Now it's heating up.
So printtopeer.io is where we find you. Gotta go check it out. Gotta download that Raspberry Pi image. I mean, all you gotta do, and how many gigs is the image?
The image itself is pretty small. I think it's under a gigabyte now, and then it expands to fill your card.
Yeah, it's 360 megs.
Yeah, it's 300 megs.
It's about 300 megs. So you just need a little. You don't even need a very serious SD card to run the image, and it's not like a typical like a Debian Linux. It doesn't have a graphical user interface. It's only meant to be a remote, like a remote solution. It's really meant to be tapped into remotely via this web interface. It's not meant to be, like a full-blown operating system for your Raspberry Pi, right?
That's right. So it's based on Debian Linux, but yeah, there's no you don't need to hook up a screen. It's all done through the web. So we've made it as easy as possible to set up.
So there's no GUI on the thing. You're not going to hook in a monitor to your Raspberry Pi. It's just a standalone thing. It's just meant to sit there with your Raspberry Pi hooked up to your printer.
Exactly.
Cool. I like it. I really like it.
Yeah.
We got to put you in touch with our buddy over. It's Steve.
Brad Hill. Oh, Steve Hernandez.
Steve Hernandez from Creation Workshop. He would love to see what you're doing with this, and probably you do have a developer API. If you want to develop, if you're a developer, how can we get in touch with you? Is it on GitHub, or you have your own place on your website?
Yeah, so we actually have a spot on our website where you can use our print button. So it's just printtopeer.io/API, and essentially it's a print button that can be on any website or mobile app, and it sends STL files directly to your 3D printer. You don't need to download them anymore.
Wow.
So this button can be anywhere.
Yeah, so Steve Hernandez over at Creation Workshop or Envision Labs, genius. The guy's a genius, and I think you guys would really have a lot of fun collaborating together. So definitely, we'll get you in touch after the show here.
Yep.
Awesome. Looking forward to it.
Well, again, thank you, Tom, for coming on and showing your software app. And so what you need is any Raspberry Pi. I'm assuming the B Plus might be a better choice with its multiple USBs if you have multiple 3D printers. I heard there's some other advantages, too. I think the RAM amount is larger on it. It uses a micro SD versus an SD card, so keep that in mind if you're buying a card for it. And there's a couple of other benefits to it as well. But you can go out and actually, I'm going to be talking about that as product of the week. So we'll go out to that website here shortly. So again, thank you, Tom, and we'll move on with the show. Any projects you're working on, Chris?
Well, as I mentioned last week, I got my TAS one late last Friday afternoon. I had it up and running in 41 minutes. This thing is amazing. So
you're very happy with it.
I'm extremely happy. I have to say, this thing, I'm really surprised how far they've come in such a short period of time. So machine ALIF objects. So some of the upgrades I've been working on.
Why don't you show us?
Yeah. So well, first off, here's my TAS over here, TAS 4.
Cool. Can you bring that? Do you have enough lead to bring it in a little closer?
Bring it in a little closer.
Yeah, that. Wow.
Printing.
I heard some noise in the background. Thought it was like little crying kids, but no.
No, it's my singing little Taz 4.
Yeah.
The thing is just really impressive. The quality of prints that come off of it. So I'm really happy. I'm just
So
printing on the
what do I see in the
24/7.
background there? It looks like it's sad. It's kind of crying back there. What is that? The Rostock Max in the doorway, keeping
Yeah,
its
my
head
roast.
saying, "Don't
Yeah, but
forget
now,
about me."
so I didn't have any space on my desk or kind of anywhere here, so I kind of had to move the row stock out. But it's a great printer. I have a couple upgrades that I mean, that's my Tinker machine, so that's the machine that I like to do all my the fancy testing on, see how I can make it better. One of the downsides I see with these deltas that I really am hoping to see somebody come up with a solid solution for in the next few months is direct drive delta, because the direct drive extruder is just better than the Bowden. The Bowden has a lot of problems. You have a lot of filament feed issues. The extruder just doesn't have as much torque without jamming the material in the head. There's a much bigger. There's another variable put in there for failure essentially. So I have some
Well,
testing I want to do with that. But I'm definitely going to look forward to using this print-to-peer solution as my driver for my row stock, because now I can put the thing anywhere in my building. I can put it anywhere and sit it there with a Raspberry Pi Raspberry Pi did release a new one earlier this week. I don't know if you read about that.
yeah, we're talking about that.
Yeah, well, you were talking about the B plus. I've got a B plus here, but apparently they came out with like an A plus. I think it was an A plus
No,
Yeah,
I
that's
earlier.
right.
think
Yeah, they came out with an A plus earlier this week. $20. They have a
Oh, you mean the lower cost version? Okay.
lower cost version. Yeah. So, but I will quickly touch on some stuff that I've been kind of experimenting with on my Lulzbot. One thing that they include is this PET tape, which is really great. I haven't had any problems, especially when I use the glue stick. I just put a little fine glue stick, just a regular Scotch glue stick, on the surface of the PET tape, and it's been working really great. But one of the things that I have heard is even better is this Ultem PEI, high strength Ultem sheets. So down here, a 12 by 12 sheet. You can buy a sheet for about $20, and you can just score it down to the size that you want, whatever your build size is. So for a 12 by 12, which is essentially what the Lulzbot Taz 4 is, I bought a sheet for $20, and so that's my project for this week. I'm going to be looking forward to putting that on and kind of testing. I guess bed adhesion is that much better. So I've got a. I can show it. This is what the sheet looks like. It's really high strength stuff, and it's known for
What? That's the
super
PET
high
sheet that you
adhesion.
were talking about?
Yeah, it's supposed to be the stuff that everybody's starting to switch over to for ABS printing, nylon printing.
Is your bed that big?
Yeah, the bed is.
That's impressive.
Yeah, it's about a 12 by 12. It's
Wow.
Yeah, no, the Lulzbot really has it figured out with this one. They announced they're coming out with their mini. The other one that I haven't, it's printing so well, and I'm kind of doing my first testing with the single-headed extruder, but this came with it too, is a dual-head extruder. This side here is they call this nozzle the Flexi Dually, because it not only has two Budish nozzles, but one side is specifically designed for flexible materials.
That's a behemoth.
It
That's
is.
huge.
It is huge. It's a big head.
Yeah.
But the coolest part about this Lulzbot is not only is it open source, so you can print any part you need. They have the full bill of materials. They're Open Libre, so Libre 3D. They're a big supporter of that whole thing. Not only that, but the extruder is literally one bolt. So you undo one bolt, you pop, you can change out the extruder. The whole head assembly you can pull off with one bolt. And bed leveling, super simple. They really have done a lot to make it easy. So I'm really impressed with this Lulzbot. it's been a really fun experience. So I'm kind of giving them a plug.
I'm sure we'll find all those innovations in the next MakerBot.
Yeah, yeah, exactly, and then they'll patent them.
Tom, tell us how you really feel about MakerBot.
Yeah, and I actually was on the phone earlier this week with a Stratasys rep because I run some Stratasys equipment here, and I keep telling him like, hey, you guys gotta step back into this game. I mean, I don't run a MakerBot, but Stratasys now owns MakerBot, and the commercial machines, more and more of these little machines are so much more practical for iterative design, especially so for prototyping and service bureau shops, and these small machines are more and more being able to compete with these big dog printers. So
we can't use the term thumbs up because it's trademarked, so let's come up with our own thing. I don't know. Tom, maybe you can help us here. Come up with our, I'm assuming you're giving this a 100%, 1 out of 10. What do we want to call it? Full exclusion? No. Two
rating.
extruders?
Yeah.
So you give it a positive rating?
The Taz?
The Lesbot.
Yeah, we've gotten some good reviews of those machines.
Chris?
Oh yeah, I'm a full believer now. I mean, I already had done my homework and done a lot of research on which one I was going to add. This is my 4th printer, and so I mean, this is what I live now. This is my life. I live in the service bureau world, so I take this stuff dead serious. I've been doing a lot of research over the last few months, and so I'm pretty sure I picked the right one. We'll see. I want to do a few hundred hours of testing, obviously, before I do make any definitive decision. But as of now, I'm just thoroughly impressed.
I'm glad to hear that. Okay, well, let's move on to my project. On Wednesday, I was part of a panel, Technology in Medicine, that was done with our local Softtech group. And I streamcasted, but one of the things that I thought I would do a little differently is that, I hate to say it's the big thing in the news, but more from a negative perspective. Everybody by now has heard about the Ebola virus, and from one way or another, yeah. But obviously, there's a huge concern. But I thought, well, what in the 3D realm have people been doing with it? And one of the things that I found in my research, and I'll pop right over to it, is Designs You Trust. I guess a graphics designer, 3D modeler, had actually, from scans and so forth, created a full implementation of the Ebola virus, including the interior structure. And if you've seen some of those that have been on the news, one of the things that I found that was missing is these little protein, what would you call them, like Velcro latches. And this is the important thing. And the other thing is, and I'll drop to another camera because I printed out a less detailed model, but it will give you a better indication of what it looks like. So I'll pop right over to it. So if you see right here, this is my little interpretation of the model. Can you see that? So I printed this on a Form 1, and essentially it looks like a worm, snake, or something like that. And that's what makes this, what would you call it, so insidious, is because of this and its length, it can really attach very quickly and determine onto human DNA. And obviously, as you know about viruses, they mimic and create a whole mess. So because of its length and its snake-like, or what do you want to call it, worm-like shape, it can entangle much quicker and, as we know already, more deadly than many other viruses that are out there. So it's very interesting that we're taking a look at things now from a 3D perspective and modeling these things to work like that. So it's kind of cool. But if you want to find out more, like I said, there is this poster here that you can head out to. I was hoping to have some more information before coming on today, but they haven't written me back yet. This was actually, I think, made in 2011, so it's been around for a little while. But it kind of gives you an idea of the type of structure itself and what it's made of, and then as you can see here in a more magnified view, the certain nucleides and the proteins that make up this particular virus. So if you want to know more about it, I'm not going to get into any more medical or technical perspectives because, frankly, I don't know. But from a 3D, I think we're seeing more and more of we're able to take the same kind of slicing techniques that we see in medical scanning and apply it through electron microscopes and other things in order to create extremely detailed 3D models that you can turn and move around. So pretty cool. If you go out, I was hoping to get TurboSquid back up, but for some reason their server might be down, but I get an error. But TurboSquid, if you're not familiar with them, they provide a lot of 3D models, and I find a lot of them pricey. There's a few others, but if you want to find a 3D model to either start from, to embellish or modify, I think that's a good location. Like I said, they can be pricey, but they vary. I was able to find a $6, like I said, the one that I printed that I modified a little bit. It came with a UV normal deformation, which is normally used in gaming in order to provide texture, but I baked it in and was able to create the deformities in the mesh in order to print it properly. And if you look really close, I'll put the model up or a link to it, but you can actually see these little areas here on the model itself, so it's kind of cool. So that was kind of my project this week, and that's kind of how I ended my portion of the panel, was talking about this and how 3D is being used not only in creating components for the human body, but also in research as well, and this is a good example of that. So on to products of the week. As I mentioned, I wanted to talk about the Raspberry Pi, one, because we have Tom on, but the other thing is that they came out, as Chris said, a new model called the A+. And I apologize, Tom, I guess I mixed the two up. The B+ still is a larger unit with 4 USB ports, and it still has the SD. The A+ is the one with a micro SD, if I remember correctly, and as you mentioned, a 1 USB. But what is the size of this? Like less than 2 inch? I mean, it's very compact.
Amazing.
But still, yeah,
I mean,
it
how do
still
you
provides
have an HDMI port for $20? Alone all this computational all this power that it has.
Well, this is the key right here. Can you see? Is my mouse going over this?
I don't see your cursor. I kind of see some stuff highlighting though.
Okay, how about now?
Oh, there we go.
Okay. Well, this is obviously a larger view of it, but the center chip is the big reason that you can make these smaller and smaller. As we're using SDMI techniques, or surface mounting techniques, we can get more things on these boards. But notice they still provide the expansion port, which is kind of neat. So everything else has been shrunk. And they have a display over here, which is interesting. You got your HDMI. What was the display port here? Do either of you know? Have you worked with it now? Off to the left-hand side.
Oh,
sorry that my.
No, I don't. I have not used that. Oh, it may be for if you have like they have Pi compatible LCDs. I know. So that might be what that's used for. I'm not sure. I'm not 100% though.
And Tom, can you still hear me over there?
Yeah, I can.
Okay. So this is I guess the camera slot. So when you were talking about the camera, you were talking about the specific camera that you buy for the Raspberry Pi. You're not talking about a standard webcam that you would plug into a USB port.
That's right. Yeah. So
okay.
I think the connection on this board, it's on the left. Or sorry, it's at the.
Yeah, it's right next to the HDMI on the right. Yeah.
That's right. So it's just a ribbon cable that goes to a little circuit board.
Okay, so I'll have to look into getting one of those. And then it looks like it's got a micro USB down in the left-hand corner, or bottom left-hand corner for power in. And then this is what I remember. It's kind of funny, they're still carrying it over, but it's the composite out connector. Was that the audio? Yeah, it's the AV, which has, I believe, a composite video as well as an audio signal that comes out of that little 1/8-inch jack there. So, and then you got your standard USB port over here on the right-hand side. So very compact, cool. I think the memory is the same as the previous versions. So yeah, kind of neat. And as you indicated, it's $20. So I It is not available on Amazon, but I think you can. Can you order it directly on their website? I don't think so. So I don't know who's carrying it. Well, let's see where this. No, there's nothing there. So if somebody knows of where you can get one of these, let us know. Here we go. Nope, doesn't come up. Let's see.
I know Element 14 is usually.
Well, I'm assuming that it's going to be available,
Yeah.
if not already, very soon. However, if you want to, as Tom alluded to, if you want to control more printers than just one, I think the B Plus, which I think I bought on Amazon for 35 bucks, Prime member, so actually they told me I was going to get it Saturday, but it's already going to be delivered today, so that's kind of cool. So I'm kind of
Unbelievable.
excited. I've never really found a real reason to have a Raspberry Pi. I've done a lot of Arduino work, but now I guess I have a good excuse, thanks to Tom, to actually putting one to use and seeing how it works out. So that's kind of the projects and products on my end. I think it's time for the Print Whisper.
Well, the Print Whisperer kind of already went into it, but if you're having bed adhesion techniques, or we're talking bed adhesion for your, like ABS, you're having ABS peel off of your print bed, might I remind you to try out PET tape. So there's lots of different places around there. Lilsbot carries some. This is
Isn't there a
PET
company
tape.
that went on Kickstarter called Gecko? I've got something
Yeah,
like
and,
that
and
coming in
essentially
soon.
what they're, so there's all kinds of different people doing all kinds of experimenting in the rep community. This is 3M's PET polyester film, and a 12 by 12, a 5-pack will run you about 30 bucks. Or like I was saying a few minutes ago, you can try out this Ultem PEI. A lot of people having really good success with this. You just lay that right over your glass, your heated build tray, or your heated build platter, and you just make this your. So if you're having trouble, you're using masking tape or all these little tricks that people have been using in the past. People are starting to see the light with things like PEI or PET as your build surface, and you can still use glue stick. So some people are still like me. I use a conjunction of the two. I'll have the PET tape on my build surface, but I'll just use a little Scotch permanent glue stick. Just put a very thin layer. You don't want to throw off your calibration or your leveled bed. So just throw on a little coat of this, and I'm having absolutely no peel on my heated bed. So
Yeah, I've been using the uh, the the glue stick for some time now, and I had pretty good luck with it.
yeah.
Uh, since it's colder now and I don't have a heated room where my printers are, I'm finding that I'm getting a little more curling than I want, but I fixed that. I now have heaters in there now. As you alluded to, Chris, are you planning to build a container or an environment chamber for your low spot?
Yeah, eventually. I have not run into too much warpage, but I foresee I've got some more materials like some of the new Talman nylons on their way. That's one of the reasons that I, have really been moved to even get this machine, is because my row stock was having quite a bit of trouble printing nylon, printing the flexible materials. The Bowden drive is just not optimized for some of these other materials. So the direct drive is really, that's where it shines, is with these other materials. So nylon, things like that. But those are known to have more warping issues. You can oftentimes correct it with a heftier brim, but build your own enclosure, or building some sort of enclosure for my printer, definitely high priority. So I'm definitely working on that, and that's one of the things that's nice about having an open source, having the CAD files all there online, is I can just pull it all into SolidWorks and make my own and come up with my own design that's perfectly accurate. throw some sheets of acrylic on the laser and cut it out or whatever, and come up with my own design real easily. So
Very, very cool. Yeah. So I'm hoping that Gecko, whatever, comes to me soon so that I can try it out. I think it's very similar to that. Um, and I wish I could make a better housing for my replicator too, but right now it's kind of dead and I'm making some changes to it. So I'm hoping I can find a dual extruder to make it turn into a 2X, but maybe not. So I want to get on to one other item and then we'll close it for the day, and that is Software 101. A lot of you may have problems getting something to print correctly. I've noticed I just received a print from an engineer I'm working with. It's a container or a retainer for an IC chip he's working on, and we're going to make it out of conductive ABS. But when I started printing it, I noticed it would only print like think of it as a square, but it would only print the sides but no corners. And after looking at it, and I failed, I assumed that it was a good STL, but normally, this has been my de facto application, NetFab. I bring them into NetFab and I give them the once over. And one of the things that I've noticed that happens a lot in people who do solid modeling or even some organic or mesh modeling is it comes in with multiple shells. And I found that multiple shells can create some pretty big problems when they convert it over G codes. So one of the things that I do on a regular basis now, one, you go to the repair, and if you have the free version, some of these controls won't be available to you, but the auto also does this feature. And one of the things I look at first is do an update, and it tells me how many shells. As you can see here, this is just one single shell. But sometimes you have multiple shells, and this happens a lot if you have a multi-part object. But a lot of times you don't want it to print as multi-objects because the G-code sometimes gets messed up. So what I normally do is check to see the number of shells, or if I'm scanning something, I may have a lot of loose shells that don't really do anything, like 2 or 3 polygons. So you'll get a list if you go to shells of all your shells, in this case 1. So if you have some minor shells that don't make any difference to the model, like floating things, you can just highlight them all and delete them. So that would be the first thing that I would do, and that would get rid of all those extraneous shells and bring it down to the center object. As you can see here, this is one object. Once I'm done with that and have it down to a few, then I can go in, as long as the polygons are connected to one another, I can go into actions here and then wrap the part surface. And what that does is go all the way around the object and literally kind of wraps it into one surface. And I'll do it here because it's quick, and obviously it was already one surface, so I don't have to worry about it. But what will happen sometimes if you are wrapping multiple shells that are touching, you may get some degenerative faces, and they show up in here as amber or orange lines. And then you just go to remove regenerative faces, and then you hit apply repair, and then remove the old part or keep it if you want to have something. And you should get no message down here. Normally it's a big exclamation point saying you have a bad model, and then it should be green. Then you can take that part and go to export as STL, and then notice it says that it's been repaired. So you can either leave that in there to identify that you have a repaired model or name it whatever you want to. And then send the ST out, and then bring that into your slicer. And I found that that has been very effective and has really reduced the number of parts that don't seem to directly translate over into proper G code, because it tries to separate all those shells into different G code processes. So I found that this to be worked very effectively. Like I said, the free version has some auto tools that do the same thing. I found that I don't rely on them as much, because if you have a large number of polygons, it can literally crash it or literally put it in an infinite loop, and then you'll have to exit out of the application. So I try to do things minimally, especially some of the scans that I work on that can be 2 million polygons. That makes a big difference, and unless you've got a really beefy machine, it can take a while. So I try to do that in baby steps, and the auto mode kind of just does everything at once, and then you really don't have a lot of control over it. So, I've talked about NetFab in the past. Very powerful program. There's a free version, there's a private version, and then there's the Pro version. Private version, I think, is $200 to $300, which is an excellent investment. You cannot use it for commercial use, and then there's the Pro version as well. So that's it for software tip. And I didn't look to see what's upcoming in the 3D world, so
Well, we've
I
got
apologize for that.
Yeah, so I don't think we have anything on the agenda quite this week. So
No, we've got Thanksgiving coming up. I may have an interview next week with Daub, which is a group out of Germany who's created this really, really interesting photogrammetry type booth. It uses a lot of high quality cameras, and they can capture in 1/100th, I think it's 1/100th of a second, 3D models. So
wow.
they can do almost motion capture, I guess to a certain extent. So you've got a 1/100th capture capability with extremely good detail and textures. So hopefully they'll be, and they're planning to bring these booths into basically all the way around the world. They've actually got 2 locations right now. I think one is in Dusseldorf and then one is in Berlin, but they plan to go outside of that. So I'm hoping to talk to them next week. Other than that, I don't think we have a roundtable scheduled this month. I haven't invested any time in it with Thanksgiving come up, so we'll probably do another one in December. Is that all right, Chris?
Yeah, that sounds great.
Okay. And hopefully we'll get Tom back on when he goes out of beta, and then we can talk a little bit more about it. And, Tom, it looks like you had a little bit more to talk about than 10 or 15 minutes, so I apologize for cutting you off short. But maybe we can come back on as an interview, find out more about your background, what your interests were and so forth, if you don't mind. So,
And
no
maybe do a
problem.
little, maybe do a little tutorial of the setup. We could go through the whole process. We'll cover it all from start to finish, however long it takes.
Yeah, and the one thing that the one thing that we missed today was voice control. So I can actually control our printers with my voice.
You don't call it Siri or something, right? Or what's the Microsoft?
Cortana.
I don't know.
No, I can
Cortana,
do,
and Amazon's got
I can do
their.
the tea Earl Grey hot.
How very good.
Yeah.
Okay,
Awesome.
well that's it, Chris. So why don't you kind of end it for us again?
All right. Well, thanks to our listeners and our special guest Tom today, and we've covered a lot of bases. Hope you learned as much as I did, and we'll see you next week on All Things 3D.
Bye.